Hello, everyone, and welcome to today's session. I'm Ken Underhill, your host with DZone. Before we get started, just a quick few housekeeping notes. Today's session is being recorded, and the on-demand replay will be shared after the event. And if you have any questions at all during the presentation, please submit those using that Q&A panel, and we'll try to address as many as possible during the live QA at the end. Now, let's get started. Modern cloud platforms have given engineering teams unprecedented scale, but also unprecedented operational noise. Today's SRE and DevOps teams are buried in alert storms, fragmented telemetry, and manual root cause analysis that slows response times and turns every major incident into a war room. In today's session, we'll explore how a new class of operations intelligence, Agentic AI, is transforming incident management by moving teams from reactive troubleshooting to autonomous insight. Joining us is Grant Griffiths, founding engineer at NeuBird.ai, where he leads infrastructure and platform engineering. Prior to NeuBird, Grant spent over 5 years at Portworx, which is now part of Pure Storage, where he served as technical lead for the Portworx CSI driver and leading Kubernetes open source community engagement. As a core contributor and reviewer in the Kubernetes community, Grant has spoken at events like KubeCon, GopherCon, and HashiTalks on topics ranging from CSI drivers to resilient data pipeline. So Grant, welcome. We're excited to have you here today, and I'll hand it over to you.
Yeah, let's get started. So yeah, as you mentioned, we're going to be talking about alert storms today and how you can take that to autonomous insights. So yeah, a little bit about myself. He already gave the intro, but I've been at NeuBird for a little over a year now. So I started off working on the core agent, and then I got into infrastructure. And then, customers needed private cloud deployments, so I helped with that. And now I'm kind of more on the solution side as well, kind of giving talks and kind of promoting the product as well and working with customers. And yeah, prior to that, I was at a company called Portworx for a couple of years with the same co-founders from NeuBird. And I was a contributor to Kubernetes, Nomad, and Go at my time, previous roles. So yeah, you may be wondering, who exactly is NeuBird, right? So we were founded in late 2023 after a couple of decades of our founders working across different software stacks in the storage space, working at Portworx and at other companies and Dell and all of that. And the common underlying theme that the founders had within all of these companies is that, man, it's really hard to debug production issues and debug, issues at scale, right? So we'll get into that today and why that's important. But yeah, the company is backed by Microsoft's M12 and Mayfield, and you could think of it as your production ops agent. So what we do is we prevent incidents, we resolve them, and we also optimize your infrastructure as well. Here's the team. It's a little bit of an older photo, but here's our team in our Redwood City office. We have meetups and events, so feel free to stop by and meet the team. So today I want to talk to you about why SRE is the best use case for Agentic AI. I know you probably have heard that before. You may have seen an advertisement for other agents and stuff like that, but I really do strongly believe that SRE and production ops is going to be the biggest problem to solve with Agentic AI. And yeah, so I know what you might be thinking, right? You've heard that before. Agentic AI, it's going to solve all your problems, right? But today I'm going to show you about how we've made that a reality here at NeuBird and how it's actually been helping us debug a lot of our own internal production issues and a lot of other customers that we're working with as well. So yeah, let me explain. Give me some time, and you'll see exactly what I mean. And I'll show a demonstration later today about how we can tackle this problem. So just a little agenda for today. We're going to be talking about the observability problem and the history, a little bit of observability to give a little bit of a background into the problem space. Then we're going to be talking about how the SRE role was created before the age of AI agents to address this problem. Then we're going to talk about NeuBird and how our prod ops agents can handle a lot of these issues for SREs and can handle a lot of the incident resolution, doing predictive analysis, and optimizing your environment. We'll also do a demo of both our UI and then our NeuBird CLI as well that's in tech preview. And then we'll do some takeaways and Q&A. So just to give some context, right? A lot of it's basically, I'll start with this slide, microservices at scale, right? So at Uber, I think anyone that's been to tech meetups and different webinars and in the space, they've heard about microservices and how Uber is using them, right? So specifically, in 2013, they started with around 100 services, right? Then by 2016, they had over 1,000 services. Later, a couple years later, another 1,000 services, up to 2,000 services, right? So what happens when one of these services go down, or what happens when one of these services go down, right? So basically, what ends up happening is you can't request an Uber, or you won't, your Uber driver will look like it's stuck somewhere, 10 minutes away, when in fact he's calling you right now and he's looking for you, right? So what Uber did is they developed something called Jaeger, and this tool is specifically built to address problems like this. So back in 2015, 2016, when Uber was tackling this problem, I was attending a lot of meetups, and Jaeger was definitely like one of the top tracing tools out there. You had Zipkin and other things as well that were kind of early adopters, but Jaeger and then a lot of other tracing ones, Lightstep and a bunch of other ones came up later as well. And traces are pretty much in every observability platform now as well. Datadog, Dynatrace, and all of them, right? So these tools were all being developed before the age of AI agents, and they're providing a lot of great context, but they're all still trying to tackle the same problem of how do we actually make production environments more reliable. So yeah, that's pretty much what I'm getting at, is that we solved visibility, right? But we created a fire hose. So now, instead of after Jaeger came out and tracing came out, now you already had to look at dashboards, metrics, and logs. So now you have to look at traces as well, right? And what do you look at first? Do you look at traces first? Do you look at logs first? After looking at the alarm, do you look at metrics? Is there a certain dashboard you usually go to when a production issue happens for a given incident type? Do you have metrics that you wish you had a dashboard for, but dashboards are very time consuming. It can be very difficult to make Grafana dashboards, and anyone that's worked with Grafana knows that it takes a while to get a dashboard correct. You might spend a couple hours, building the right queries, building the right dashboards, and then then the next one comes, and then you need to make another dashboard. So a lot of these observability tools made this quite a bit easier, but the problem at the end of the day is still that we have too much data, too many dashboards, too many metrics, and too many logs and traces, right? So in 2026, the problem isn't a lack of data. In fact, we've built such amazing tooling around the observability space that we have way too much data, which is a good thing, right? But that's essentially why Agentic AI has been so successful in terms of coding agents and a lot of the other customer success tooling out there that exists. They're basically taking all this context and making it into meaningful results. So not only that, but each one of these observability data points have different pros and cons, and they can be difficult to work with in an isolated space, right? So logs are very unstructured. You might, it's trying to find like a needle in a haystack when you're looking for a bad log line. You can filter by errors, but it takes a lot of time to look through the logs and make sure that it's not a false alarm or a false flag, right? It's not a red herring. Especially if you're not familiar with the product and you're not the one who is writing that log line, it can be very difficult to see, is this log actually causing an issue or not? So we'll talk about how that log can be looked up later and cross-checked with GitHub to see, is that log line actually an issue in the code, or is that log line just a noisy log line that's, not really an issue? Metrics, the high cardinality can be an issue. You can have so many metrics, but you can only have so many dashboards that a human will remember to look at and use on their day-to-day basis. Traces are powerful, right? And they're amazing at cross-correlating services, but it's still very time-consuming to use on top of your logs and metrics, right? And on top of that, SREs use many other tools on a day-to-day basis to solve problems, right? So SREs, they're not just going to be opening up Datadog, Dynatrace, and all of these other tools. What they're going to be doing is opening up GitHub. They're going to be checking the code. If it's an infrastructure as code issue, if it's an infra issue, they're going to be checking the Terraform code. They're going to be pulling up the Azure login portal. Maybe they have to pull up their MFA token and log in. They have to navigate to the right portal. They have to make sure they're in the right AWS region when they're looking for the issue. they have to go ahead and remember, where's the service actually running? Is it running in this region, that region? And forget it. If it's a new teammate, then they have to be caught up to speed and they have to do context sharing, which is what we'll talk about that later today as well. For chat, you have all of this tribal knowledge can be in Slack and in Teams, architecture diagrams. In Confluence, you have all these different CLIs you work with, kubectl, AWS, Azure CLI. So these are all the different tools that SREs have at their disposal. It's not just the observability tools they're using on a day-to-day basis. So more observability data does not necessarily mean faster resolution. In fact, we are actually kind of hitting the human limit in modern production, right? When you're investigating very complex issues with so much logs and alerts, teams are getting overwhelmed with alerts, alert storms, like we'll talk about later. The MTTR just keeps growing. The time to resolve issues, the mean time to resolve issues keeps growing and growing and growing. And that has a cost on the business, right? So it can be very difficult to resolve these issues and keep your website online and keep your apps and services online and still deliver good results at scale as a company, right? So now that I've kind of been all doom and gloom about the problem, let's talk about the SRE role and why that was created to kind of solve that problem. So, enter the SRE, right? This is a reliability expert on your team that may have heard about the Google SRE book. They may have seen a talk by a Google engineer early on, or maybe later on, they saw another blog or kind of a meetup where people are talking about this new SRE role back in like 2014, 2015, and started picking up, right? And it started as a responsibility, not necessarily your role. So a lot of times it was a software engineer, it was a DevOps engineer, it was an ops person, but they just had a focus on reliability. They were the reliability expert on your team. They may have been championing tools at your companies like Datadog or Dynatrace or PagerDuty, and they had a focus on reliability. If they may have set up your on-call schedule, they may have done all these other things, but at the end of the day, it was a person that was passionate about reliability. And so that's kind of the SRE role and what it was supposed to be, right? That was the initial kind of intent of the SRE, site reliability engineer role. But that comes with problems, right? So SREs, like I mentioned, we have this beautiful graph with Jaeger now, but how do you make sense of all of this, right? And unless you can actually have like closer visibility into the logs and metrics and traces that are going on with respect to one of these services, if one of these services goes from blue to red and goes down, it can be very difficult. However, just being an SRE and knowing about all of these different services, it's impossible, right? 2,000 microservices is not possible for one human to really know about all of them. And if that's all you did at the company, then that's pretty much, you'd be the microservices expert, right? You wouldn't have time to do anything else. The next problem that we run into with the SRE space is context management, like I mentioned. So SREs, at first they'll be the ones manually kind of addressing any issues that come up. But, management will start to see, okay, we have this one SRE on the team, and they're the only one that knows how to solve if like a Kubernetes node goes down, or if infrastructure is having a networking issue, or maybe the application is like crashing and crash loop backoff. Not all of the engineers are Kubernetes experts. Not all of them are Azure AWS experts, right? So the SRE tended to be the person on the team or like another team adjacent to yours that knew how to handle all of that, right? So what do you do when only one person or one team knows how to do something? You document it, right? You added a Confluence doc, you add runbooks, you say, if the Kubernetes cluster is having issues or the node is going down, then what you do is you basically document it, right? So it ends up in Confluence, and then junior engineers or other engineers, even senior engineers, get added to the on-call schedule. And then they're told, if a Kubernetes node goes down, follow this series of steps. If the application is crashing, follow these 3 steps. Go through the logs. And sometimes those 3 steps don't exactly resolve it. And then what happens is after the runbooks have been created, you'll have a massive architecture change, right? Now what you need to do is go through all of your runbooks. Maybe you have 100 runbooks now. You need to go ahead and update all of your architecture inside of those runbooks, update all the manual commands. And, you have to, sometimes you have to leave it up to the engineer to kind of figure some of that out, and that's learned. But what I'm getting at is that this is a very difficult process for handling production issues. And in the age of AI agents, it can definitely be solved in a better way. So in addition to that, knowledge transfer. How does tribal knowledge make its way to new teammates? When someone new joins the team, now you need to explain these 100 runbooks. You need to go over architecture diagrams with them. When someone joins Uber, you need to show them, here's the five microservices that you touch, but if one of the other microservices go down, forget it. We kind of just have to throw it over to them to help look into the issue. And so we're ping-ponging back and forth between the different teams and trying to resolve them. Then finally, tribal knowledge, like I mentioned, architecture diagrams, Slack context. All of this is context. And we'll talk about something called context engineering later on. But this is all context that AI agents know how to make sense of in a much more powerful way. So we talked a little bit about this, but the next problem is doing an incident investigations. If someone gets paged in your team, let's say it's the more like junior person on the team, what they're going to do is they're going to get paged, right? The first thing they're going to do is open up PagerDuty, check that incident. They're going to, go to a dashboard and say, it's 3 a.m. Like, is this an actual issue, or is that, did Joe add a new alert and he didn't really look at the right thresholds, and all of a sudden I'm getting paged at 3 a.m. But in reality, CPU spiked for 10 minutes and then it went away. So maybe I'll just, go back to sleep, right? So the first thing you do instead of doing that is you just confirm that the issue is real. So you go into a dashboard. Next, you might go into the cluster if it's an actual CPU spike that's not going away. You check for the app status. You see what's actually going on in the application. Probably have to open up kubectl. Maybe you didn't have kubectl access already, so you need to log into the right Kubernetes cluster. So after you've done all that, you're on step 3, right? Maybe 5 or 10 minutes into the incident, you're only on step 3. Next, you're finally in the Kubernetes cluster, and you're looking at logs. You're trying to find related errors to that incident. And keep in mind, you had to read the entire incident and see, what the actual issue was, what microservice was it affecting. So more and more steps, all of these manual steps might take, a couple of minutes each, and that adds up, right? So finally, maybe a couple hours later, the SRE is going to send a fix. So what they're going to do is it might be in GitHub code, it might be a configuration change, and then they're going to have to create an RCA after, getting paged to 3 a.m., 4 a.m., and their mind's all cloudy, and now they're trying to remember all the steps they took to solve that issue. Again, this is something that an AI agent can memorize easily. They can memorize all the steps that it took to take, all of the data points it looked to solve the issue, and all of that, right? So that's what we do. The agent would create an RCA and then send it off to the stakeholders. So as I mentioned, this is all time consuming, and it's not always accurate. You're getting paged at 3 a.m. You're getting paged on top of all of those tasks that you had to do that week. On call is typically on the team is something that is a responsibility that you kind of stress about. You have 7 days of you can't do anything over the weekends. You have to always make sure that your laptop is ready. If you're gonna go to the gym, make sure you bring your laptop in case God forbid the Kubernetes node goes down, right? So you need to always be ready and on call. So you might rush steps if you're trying to kind of look into the incidents, and it might not always be accurate. AI agents don't get stressed, so there's no problem with that. And it's not repeatable and scalable, right? So if you're looking into multiple incidents, that has to be happening serial from the on-call person, and if not, then multiple people need to get pulled in to handle this. And that's not to say that it's not to say that it's not scalable. It's just that, it's just not scalable for that kind of sake. The next problem is the context depth and breadth, right? So when you jump on one of these incidents, not only do you need to come up with the resolution, but at bigger companies where you have multiple teams that you work with, the networking team, the infrastructure team, the apps teams, the proxy team, all of these different teams, right? So the problem is you have to go find the expert sometimes for that. So there's an issue with context depth and breadth. So you can only have so many experts on a given team if so that's basically the issue there, right? And what the agent will do instead is we'll go ahead and actually look at the different kind of data points across all of the other teams. We're not just going to punt it off to the other team to look at the RCA. We're going to find the actual root cause and tell the other team, hey, look, this issue is causing a downstream effect in our service, right? So instead of having to ping that other expert, that's what we would do. And yeah, the next thing is alert storms, right? So this is an actual fun fact. This is actually from one of our on-call engineers. Shout out to Daniel on his first week of on-call when we didn't have our alert thresholds set up properly. And he got called every 5 or 10 minutes. So, alert storms are real. And, once you adjust your alerting threshold to be the right way, you're not going to get this many calls, of course, but you're still going to get paged frequently for any issues. And that's the problem. You're going to be dialing up and down, which incidents do I look at right now, versus which incidents do I look at within a 24-hour SLA, right? The nice part about an SRE agent is that it will look into all of them, regardless of the priority. So you'll always know right away what incident is actually affecting the infrastructure the most, and which one do you need to really look at. And not only that, but it's kind of a reoccurring and repeating kind of a thing where basically, it'll be too many alarms at one point. So you probably scale back the number of alarms you have, and that'll result in monitoring gaps. And then leadership will ask you, how did we miss this? So the SRE, pretty much will always say, okay, let's add more alarms so that we can catch this next time. And I'll talk a little bit about it later, but this is kind of a never-ending cycle of adding more and more alarms and more manual toil to adjust these alarms. The next is reliability. So we're 5 or 6 slides in terms of what the SRE does, but we still haven't even talked about one of the words in the SRE's title, which is reliability. SREs spend way too much time on something called toil, which is manual, repetitive, automatable, and tactical work that lacks long-term value and scaling linearly as services grow. So essentially what it means is time wasted on doing manual things that really should be automated. So basically they have no time to proactively check for what could happen soon. So we'll talk a little bit later about how our SRE agent can do preventative investigations and say, what could go wrong in the next 24 hours, as opposed to, waiting to be reactive with the incident management. This is about fire prevention, not firefighting. And lastly, if it's a good week, as the SRE hasn't been paged or no one on your team has been paged, finally now you have time to think about things like right-sizing your environment, doing predictive consumption. Can I use less infrastructure? Can I optimize things? So finally, our SRE agent, I'll talk about that later, how we can also help optimize your environment. Because we have access to all of the context and the data, and AI agents are very good at understanding that and reasoning with what can be done. So I'll talk about that later and show you in the demo. Okay, so I spent the first 25 minutes talking to you all about problems. So now let's talk about the solution that NeuBird brings to the table to solve this, right? So, but very quickly, before we get into that, I've been talking for the past 25 minutes, so I want to open it up for a poll from the team. So let's go ahead and I'll hand it off to start this poll so we can see the results for that. So what cloud platforms do you use? I think you should get a notification in the webinar platform. Do you use AWS? Do you use Azure, Oracle, Google, IBM, or something else? I think it looks like, it seems like a lot of people are saying AWS, Azure, Oracle, Google. See, yeah, very, very wide spread of responses. So yeah, we'll leave it open for a little bit, but what we're trying to get at here is that there are so many different cloud platforms. There's such a depth of kind of different connection types and different cloud types that we have at our disposal. And yeah, thanks for the information, guys. It looks like mostly, it looks like AWS, Google, Azure, Oracle, a lot of very kind of balanced results right there. Everyone's using something different, right? So when you're switching between jobs and you're looking at different opportunities, it's, that's just another thing you need to think about is the context that these AI agents will learn and be able to diagnose and fix any issue regardless of the cloud platform. As well as when you're switching over to a new cloud on a new team, when you switch companies, not only do you need to learn about their ecosystem and learn about their specific runbooks, but you also need to learn new tooling, new clouds, and all of that, right? So, like I mentioned, we were talking about problems for the first 25 minutes, so I want to get to the solution that NeuBird offers. So, the three things that we kind of focus on, it's one agent, but three superpowers, right? We want to get SREs and production ops engineers, DevOps engineers, anyone that kind of works in this space. We want to prevent people from having so much manual toil. So what that means is we want to prevent people from having to spend time on incident management, spend time on doing things like resolving issues, and then optimizing the cost of your environment, performance, and everything. So those are the three things that we do as a company. And I'll talk specifically about how later in the demo today, how we do that. But for example, for preventative, what we want to do is move from reactive to predictive. So an example would be, how many P1s were actually preventable? Like how many, like in the next 24 hours, you could ask, are there any alerts, metrics, or traces, or are there any issues that are impending in the next hour or the next 24 hours? I think the worst feeling sometimes is when everything is going perfectly fine in your infrastructure or in your application, and you're kind of worried, is there like a ticking time bomb that's going to be, if it's all too sunny, sometimes you're worried that an alert storm is just over the horizon, right? So what you can do is do preventative and ask, kind of see in the future to see what could be trending in a downward path. Is your CPU slowly growing? Are your connections for your RDS cluster slowly increasing over time, but you didn't create a derivative-based alert that notices the rate in which connections are increasing in your cluster and not decreasing? So these are things that our agent will look for when we're doing preventative action. Then we have resolving issues, right? No one really wants to spend time day after day resolving production issues and looking at incidents and why they occurred. It could be very fun, stimulating kind of intellectual like exercise the first couple times you do it, but with leadership breathing down your neck, and it can be very stressful at times. So this is something that AI agents can really assist with. And then later optimizing, right? So on top of all of that toil you've dealt with, leadership or others on your team might be saying, how are we spending this much money on our application? How can we actually reduce that? But you don't have time to look into that because you've spent all of your time doing things like RCAs and fixing the actual issues at hand. So, you just don't have time to always do this. And our AI agents like NeuBird will definitely help on that. So in terms of how we actually do that, there's something called context engineering. So what that means is it basically is the art of taking all of this data that we have at our fingertips, all of those manual things that SREs do on a day-to-day basis, looking at GitHub code, looking at logs, metrics, alerts, traces, going through your Slack channels to see sometimes when an error log comes up, the first thing I'll do is I'll go to Slack and I'll search for that error log to see, have we hit this actual issue before? So that's exactly something an AI agent would do within seconds and take that into play right away. Lastly, we have memory and history. So our memories as humans, it's good, and But when we have so many different incidents and so much different stuff happening, AI agents are far better at remembering previous incidents. And all of the, not only that, but even managing a single ongoing incident, it's hard to remember, okay, what exactly was the timeline? You'll have to create a Google Doc, map out like the time limit of events. When did the CPU start spiking? What services were introducing that? What logs were happening around that time? You have to correlate the specific timeline of logs happening, metrics going up for CPU spiking, and all of that, right? So our AI agent NeuBird will do that, does that currently. And so what we do is we prevent issues, we resolve incidents, and we optimize the environment with all of this data that I talked about earlier. And on top of that, these runbooks we've been talking about, if you think about it, the way that AI agents really operate is very, very similar to this kind of very structured approach of tackling problems. And this is honestly why AI agents are very successful, is because they've been trained to operate the same way that humans do when tackling a large problem. First, you need to do discovery. You need to look, is this a real issue? Next, you need to very methodically come up with a series of steps that you would take to solve this problem. And not only that, but you might have to change your flight plan based on step 1 or 2, right? So these are all things that an AI agent will dynamically do. So it's really about dynamic runbook generation as opposed to manually looking at a runbook that's very static for one given issue. So like I said, if step 1 or 2 is something, if the results are very unexpected, the AI agent NeuBird will go down a path that is very specific to that step, as opposed to just a more static runbook result. And then in addition to that, NeuBird will also get rid of the out-of-date runbooks, right? Runbooks, the moment they're written, they can be out of date, right? Architecture might change. AWS is going to release some new functionality that might change the way your runbook needs to be written. It might be a service change or something like that. Your developers are going to push a new feature, so all of a sudden you need to write a new runbook, right? So these things are very fragile and not a good way to handle these kind of things on a consistent, ongoing basis. And also what we do is we generate remediation steps, and I'll talk about that a little bit later and how you can use them. Next, we have, we'll talk about the agentic approach. So NeuBird, what we do is we do reasoning. So we reason across all the different telemetry data types, right? So we'll look at GitHub, we'll look at Datadog, we'll look at your Kubernetes kubectl commands. We'll look at your Grafana dashboards and see what's important to you. Are you creating dashboards for CPU? Are you creating dashboards for node uptime and stuff like that? So we'll actually query the dashboards and use those same metrics queries to figure that all out. And then we do correlation. So what we do is can cross-correlate something that might take an SRE 45 minutes, could be done in seconds. And then what we also do is preventative. So we will proactively avoid incidents. And yeah, I also wanted to talk about something called semantic monitoring. So at the end of the day, alerts are written to keep your service online, right? But what you really care about is my cluster healthy? Is my app healthy? So this is alerting, and I'll show it in a little bit. It's basically something you can do to kind of automatically do monitoring based on the outcomes rather than just based on the alert thresholds themselves. And these could be ran on demand, and they could be done scheduled hourly or daily. So you might be asking, is my cluster healthy? Yes. Oh, yes, but, or no, here's why, right? So we'll give that reasoning. And then context graphs. It's very difficult to see like that service that I showed earlier with microservices with Uber. It could be very difficult to see all the different services and which ones are actually down. So we'll get into a demo in a little bit, but we have our CLI, which can do health checks, cost analysis, investigate issues, and do predict risk and all of that. Then we also have our MCP server. So MCP is Model Context Protocol. This allows you to integrate our MCP server, and it basically allows the AI agent, NeuBird, to be able to be connected with coding agents. So you could automatically fix any issue that comes up in production without having to even write the code yourself. So you want you to fully leverage the coding agents using our MCP server. Cool. So I've talked a lot about the problem with observability, the SRE response to that problem, as well as the production ops agent NeuBird's response to that. And now we're going to show a demo to see what the actual product looks like. So first, we're going to jump right into it. So before you even get started with our platform, what we want you to do is kind of introduce yourself, right? When you join an incident call, if you haven't joined the call, you're going to say, "Hey, I'm Grant. I'm on the platform team. I do this. I do that." Right. So you want to basically kind of tell us about your role, right? So I'll say I'm a platform engineer. I'm a platform engineer managing 15 Kubernetes clusters. My role is to keep the Kubernetes infra online and make sure all nodes are healthy. The apps, they might not be our responsibility, aren't my responsibility, but if all apps are offline, it's probably my team's issue. So this is any kind of context you can give, and kind of the AI agent will use this, and you can edit this afterwards to give us more context. So what are some specific concerns? So for me, I'll keep it simple and say, cost management. Leadership's been asking me to reduce cost of this deployment. Infrastructure uptime, and we want to prevent any issues before they even arise. Cool. So what we do right away is we're going to build the agent personality, and we're generating tasks and kind of customizing the environment specifically for the role that you've given us. And right away, this is connected to one of our demo environments. You can see we have a stream processing kind of environment here, where we have a Maps API that's looking at the results of stream processing from Flink, I believe. Yeah, we have a Flink cluster you can see. And then on top of that, there's a Kafka cluster as well. So what we can do next is go ahead and look at some of the alerts related to this. So we can actually go ahead and we can do a health check, and we can do all the other things that I talked about. So the next thing let's do is let's go ahead and ask, let's ask, are there any? Oops, let's go back. Yeah, let's go ahead and let's actually investigate an incident. So let's go ahead and do that. So if you want to, so we have an incident here in the bottom left. I'll zoom in to make it a little bigger. The scheduler evaluator is not processing messages. So this is a classic kind of Kafka type issue where we're not able to kind of process messages. So let's go ahead and take a look at that. So right away, you'll kick it off. And what you'll see here is that we have something called rounds and tasks. So rounds, you could kind of think of it as something that you're doing like an overarching goal that you're trying to do. So let's say you're trying to figure out like a baseline of CPU metrics, or let's say you're trying to look at what actual pod is causing the issue in production. And then tasks, what they are basically associated to each task is associated to a round. So you might have 5 tasks for one round. For example, you might do like 5 different queries just to 5 different tool queries just to get the result of one round. And a tool query could be anything from checking GitHub code. For here, it's looking at PagerDuty incident details. So right away, when you hop into an incident investigation, you're going to want to look at PagerDuty right away and see, what exactly is the issue at hand, and is it an actual issue I need to look at? So the first thing we're doing is we're looking at the incident. Then we're going to look at the service graph. We're going to search like all the different services and get a good idea of the topology before we continue. We're going to look at service graph neighbors. We're going to see like what are the actual neighbors that are closest to the service graph. You can see we're doing a specific query exactly to get that data right here, and you can see the actual output as well. We're going to check Prometheus alerts, and you can see we're already on round 21. I've kicked off this incident, kicked off this investigation, like, what was it, a minute or two ago. And it's already done something that would have taken a human a couple hours, really, honestly, to do. So all of these different queries will be logging into the portal, looking at all the different dashboards, maybe manually executing queries, Prometheus queries, to get data that aren't in dashboards, right? This is doing stuff that you couldn't even do without NeuBird's AI-SRE agent. So we're going to keep doing this. We're going to keep getting more and more data. And honestly, it's so much to keep up with that, the amount of tasks that the AI agent is doing. We're doing EKS pod logs now. Before I can even finish explaining to you, it's already looked through Prometheus logs. It's got an idea of the incident. It's gone through 40 rounds of different investigations, different associated queries. We're doing low-key log queries here as well. So we're doing all of that right now. We're doing more Prometheus queries. Then we're looking at GitHub commits, right? So we're going to keep looking at more and more data and see, is this Flink processing issue related to a recent GitHub commit? So you can see it's going through all the GitHub commit details and all of that to come up with the solution for this problem. So we can actually go ahead and look at one of the finished investigations to kind of give you an idea. So we can show here, and we'll actually give a confidence score. So we have closer to for most of our investigations, it's closer to 90 or 92% confidence. And what we'll do is actually go ahead and provide the findings that we found. So this I already ran this investigation earlier, so we didn't have to wait for it. But we found that the schedule and evaluator service is stuck in an infinite reprocessing loop due to a single Kafka message, right? So it went through all of those queries and checked through all of those metrics, traces, alerts, the service map, and all of that, and it came up with an exact root cause analysis. Not only that, but it came up with mitigations. So in this specific case, we are to restart the scheduler evaluator pod, and we are to skip the message by manually advancing the consumer group. So the Kafka consumer group was stuck on a specific message. And if anyone has, I wish I had a poll for this ready, but if raise a hand who actually has supported Kafka in production, right? The thing is a beast to manage in production at scale. So this is an exact issue that can happen. And what you need to do is sometimes manually fix Kafka, right? So we have remediation steps. So fixing the Kafka offset logic and the scheduler evaluator method. So we looked at the actual GitHub code itself to see how this could be resolved to fix it. We show all of the evidence, AI agents in general, people want to see the evidence. They want to see the actual data that we found in order to come up with this root cause analysis. So you can see all the different metrics we looked at, the Kafka topic specific offsets, the one that it got stuck at, and all of the different log analysis that we did, right? The Kubernetes states, the alert states, the code history. Just writing this alone would have taken someone, at least a couple hours just to write this down after they came up with the root cause analysis, right? So now what you can go ahead and do is connect this into your coding agent with our MCP server, and you don't even have to do the fix. You can go ahead and just tell the MCP server or ask GitHub Copilot, you can ask it, fix this RCA from NeuBird, and you can tell it a little bit about the incident, and we'll go ahead and fix it automatically for you. Cool. So that's kind of our UI approach to it. But for every person that likes to use a UI, there's another person that likes to use the CLI, right? I personally like to use the CLI, so let's show you that now as well. So like I mentioned, you could do health checks, cost analysis, investigate issues. But what I really like and what I found, I lead infrastructure at NeuBird, and what I like to do is predict risk. So let's go ahead and do predict risk here. What could go wrong in the next 24 hours, right? So we're going to conduct a comprehensive proactive risk assessment across our infrastructure. And why I like the CLI is it's actually going to show you the exact queries that we're doing and the exact data that's looking for. So first thing we're going to do is list all the different metrics. We're going to look at all the different alarm states that we have configured. We want to see what's important to the user before we actually go ahead and do predictive risk, right? So we want to check all the different alarms that have been configured to kind of get an idea of what's important to the user. Next, what we're going to do is query all this different data and see like what exactly could go wrong in the next 24 hours. So you can see at the bottom there's an investigating state. This is like the progress bar basically of how far along it is in the investigation. And then we have a confidence score. So we're not going to stop investigating until we have a much higher confidence score here. So you can see what we did here is we're listing more metrics. So we're trying to get an idea of API server current inquiries. So an example of like the exact kind of error rates and the number of queries against a given Kafka container. Next, what we're going to do is, filter based on these different metrics. And you can see, I'm not going to go through all of the data points here, but these are all of the different alarms that we're looking at and all of the different alarm history of what went wrong previously and what could go wrong in the future. So you can see the agent is firing more and more queries. Each of these things, like I said, would have taken a human, an SRE or anyone in your team quite a bit of time to look into manually, right? So we're firing more queries. We're using kind of a limit offset approach. You could think of this, maybe you would find this data by going into a dashboard or anything like that. So yeah, we'll let this run and kind of see what's going on. But yeah, you can see it's actually looking at the Kafka CPU throttling. And after all of that, what it's going to do, looks like it's getting close to finishing. So it's providing a comprehensive proactive risk assessment as of this current time, covering the next 24 hours. So risk number one, right away, Kafka CPU throttling. So our Kafka cluster is actively getting throttled. This, if it's not checked right now, if a Kafka cluster is getting throttled and it's not able to keep up, then all of a sudden your messages aren't going to be processed. If we're a credit card company, if we're Visa or if we're American Express, all of a sudden transactions aren't going to be processed in the next 24 hours, right? We're falling behind on message processing. So now, there could be an outage when we're not meeting our SLA in the next 24 hours, right? So you might run this on a Friday evening. I personally hate getting paged on the weekend. So I would say, okay, what issues could go wrong in the next 48 hours, right? You want to know what exactly could be causing the issues in the next upcoming hours. Then we're going to look at the Lambda function data gaps. So you could see all of the different proactive things that it's looking at. And then it's going to look at like memory pressure, and that's a high kind of risk. And it's going to look at other things like a little bit lower risk as well. And we'll summarize that. So we'll do a summary at the bottom, and we'll provide recommended immediate actions. And like I said, I wish I had more time to show you, but you could just instantly connect this data up to our Hawkeye MCP server, and you would instantly be able to look up or do the fix right away. So I've shown you both the CLI. We can do other things with our CLI. So you can have like cost analysis. You can connect skills. You can look at all of the different preventative things that I talked about, cost analysis. And we can also do in investigations. So what I'll do is I'll go ahead and I'll do the same thing where it's for this specific incident. Let's go ahead and investigate this, right? I'll kick this off just so you can see, but you can see look into recent incidents with Kafka processing. You don't even have to give it the incident, to be honest, because it's going to find it right away. So it's going to list the incidents, find that, and do an investigation for me. But now I got other things to do, so I'm just going to let this agent run in the background because I don't want to watch it. I don't want to watch it run in the background. So yeah, that's a little bit about our demo. All of this is available today. So feel free to reach out and try out the product. But the next thing I want to talk about is our takeaways and Q&A, right? So if you take away anything from this talk, remember these three things, right? So alert storms, what they are being able to deduplicate and tackle an entire storm, right? If multiple alarms are coming up and you need to solve all of them together, what we want to do is tackle them all as one incident as opposed to tackling each individual alarm. It's a totally different approach to doing incident management, right? And not only that, imagine if you could prevent storms, right? Imagine if when you're looking at the storm forecast, you could just turn it off, right? that's what you can do with NeuBird is look at the forecast and totally avoid that alert storm in the first place, right? The next thing is AI agents and production ops. AI agents, SREs, production ops, DevOps, whatever the title is, they're a perfect match to reduce toil. And that's not to say that, AI agents are, it's not to say that, we're going to entirely replace the team. What it basically means is you can focus on other things on your day-to-day basis that AI agents can do that kind of take off and reduce the toil, right? And like I mentioned, storm prevention. We want to cancel that cloudy forecast, and ideally, we don't have to deal with the storm. We want to move the storm somewhere else, right? There's a QR code. You can scan that to try out our product. We have a free 14-day trial. I'll leave it open for any Q&A, any questions. So Ken, I'll hand it off to you there and we'll continue onward.
Yeah, well, thanks, Grant. That was an excellent overview of how Agentic AI programmatically reasons across telemetry to help generate dynamic investigation workflows and reduce that MTTR. As you mentioned, we're going to move into the Q&A portion. I know we're coming up on time. So just a reminder, if you do have a question, please submit it in that Q&A form. For any questions we don't get to, because there are a number of them in the chat, the team will work to answer those after the event. So they'll communicate answers to those probably when the on-demand recording is also sent out as well. So just FYI, if you did ask a question that we don't get to, we'll do our best to answer that after the event. So I want to jump right in. Earlier in the presentation, Grant, you talked about tracing. And so one of the questions in the chat early on was, did tracing actually solve any issues for you personally?
Absolutely. I would say tracing, like I mentioned, is a very powerful tool. So being able to correlate across microservices and see a request coming in from an API gateway and eventually making its way down to 3 or 4 different microservices and seeing one of them fail. That's absolutely was not possible before tracing, right? That was the major innovation with tracing. The nice part is that AI agents will look into, NeuBird will look into that automatically for you so that you don't have to pinpoint which trace and which metric correlates with each other, right? But yeah, great question. Tracing has definitely solved a lot for me.
Excellent. So there's a few questions around environment. I'm actually just going to kind of combine those into one long question for you, Grant, if you don't mind. So a lot of organizations will not allow data to be sent outside of their environment to an agent. So first part of the question is there an ability to deploy these agents within the customer's environment? Along with that, a secondary question is, do you deploy on-prem, which kind of goes along with that same question? And then also with that, is there an ability for customer provided models for the agents, or is it only models from NeuBird?
Yeah, so in short, yes, and yes. So we do support the ability, we have a SaaS offering where you can sign up for the product right away. You can go to NeuBird.ai and try the product right away, and you'll get an instance immediately, a SaaS instance you can try out. So if you go to our website, you can try that out right away. But we do offer a private VPC deployment option as well, or virtual network deployment option as well. So I didn't talk about it in our talk, but I'll probably create a blog or something about it soon. I run infrastructure at the company, and we support the ability to run inside of an AWS VPC. So if the data can't leave your VPC, you can use Bedrock models. You can deploy our application, our agent directly inside of your VPC. You can bring your own VPC, and we'll deploy our internal environment inside of basically our entire SaaS environment into your VPC. So that's one approach. We also have a Helm chart, so you can deploy us into any Kubernetes cluster. So that allows for on-prem deployments to answer that question. So yeah, in short, we can deploy in any environment, any agent. We can deploy NeuBird into any environment, and yes, we can work with any LLMs. So if you want to only use Bedrock, if you want to only use Anthropic, if you want to only use Azure OpenAI or Azure Foundry models, let's say that you have an Azure private virtual network that you want us to deploy into. The only thing we ask is that you have access to some frontier models like, Claude Opus 4.6 and or some of the newer OpenAI Codex models that have similar reasoning, right? So yeah, in short, we can deploy into any environment. We can work with any LLM, again, as long as you're willing to work with us on that.
Excellent. So final question for you, Grant. How does NeuBird determine the most likely root cause of an incident? And part of that question also, are there like specific signals that you're kind of weighing over others to make that determination?
Yeah, absolutely. So we first do like a discovery phase where we kind of like when someone gets paged, first we do the discovery, then we try to see what exactly the issue is, and we try to look into it deeper, right? So what we'll do is we'll come up with an entire chain of thought and reason through all of the different data points, right? So it's a constant feedback loop. And what we'll do is actually, we have constant evaluations. So we have a team of brilliant AI engineers and LLM experts that do evaluations. So we're consistently trying to see how can we improve the quality of results for our customers. And we have an internal like test manager to reproduce a lot of customer environments. And we're always gauging the success of our agent. But yeah, what we do is we cross correlate between all the different data points, and we take them sometimes with a grain of salt, and we'll cross check the GitHub code, for example, for a log to see if it's a valid log or if it's a bad log. So yeah, all of that, basically the agent will take a full look through of all of your different data points. And then for an incident investigation, what we actually do is we have a peer review system where the incident will get peer reviewed by a senior SRE agent, essentially. And for that, what that means is we hand it off to a very good frontier model to review all of the steps that we've taken and all the different data points that we've gotten, at least kind of a summary of it. And what we do is we adjust the path or continue the investigation if it's not thorough enough, right? So it's almost like someone's peer reviewing or kind of looking at everything you've done without the feeling of like someone kind of looking over your shoulders and telling you, do it this way, do it that way. So yeah, totally. We definitely handle that as well.
Excellent. Well, that's all the time we have for today. Grant, I want to thank you again for sharing your expertise and for helping us understand how autonomous reasoning systems are reshaping modern incident management. Just a reminder for everyone that joined us, any questions we didn't get to, the team will work to answer those after the event. So again, thanks everyone for joining us. We hope today's session gave you practical insight into reducing alert fatigue, accelerating that root cause analysis, and evolving toward more intelligent, resilient operations. If you'd like to revisit the session or share it with your team, as I mentioned before, the on-demand recording will be available soon. And on behalf of D-Zone, thanks again for attending, and we look forward to seeing you at an upcoming event.